Okay. All right, so now we're going to look at section 8.3, and this deals with functions this time. And out of that section, we're going to be recognizing the concept of a function, including the domain and the range. Also, we'll recognize different representations of functions, and also we'll evaluate the composition of functions. Okay, so now in real world phenomena, we can model functions. And what we're going to be looking at in this section is the many different ways functions can be represented. One as a rule, another as a machine, another as equations, another as arrow diagrams, another as tables, also as ordered pairs, and finally as graphs. So pretty much there are like 7 different ways that we can model a function. First we'll look at is a rule between 2 sets. Now, one person can think of a function as a rule whereby when one value is given, the function or the rule specifies a resulting value. So like in this example here, example 1 that I have. What would be the rule for the following responses, like in part A? Student gives the number 1, the teacher responds with an answer 3. Then 0, 0, 4, 12, 10 to 30. What would be that rule for that table? You multiply by 3. Student says 1, the teacher multiplied that number by 3 to get 3. Student says 0, 3 times 0 is 0. For this one, for 4, 4 times 3, that's 12, and for 10, 10 times 3 gives you 30. All right, now what about this one? The student gives an answer of 2, a number 2, the teacher says 5. 3, then 7, 5, 11, 10, 21. What do you think that would be? Well, not quite.
Increases by 3.
About 11.
Oh, is it?
Well, let's look at this one right here. That's a good rule. A table there. And to identify that rule, all right, so we have 2, 5, and then 3 to 7. And then from 5 to 11. Good. There we go. That's it. Take 2, multiply by 2, and then add 1. That's the rule. It's 2 times the number that the student gave, add 1 to it, and the teacher would set 5. For 3, 2 times the 3, that's 6, plus 1 would give you 7. For 5, 2 times, and then for 5, plus 1 would give you 11. And for 10, 2 times 10. And then plus 1. That'll give you 21. So that rule would be something like this: 2 times n plus 1. Okay, questions on part B? Now, what about part C? We got 2, and then 0, 4, then 0, 7, and then 1, 21, and 1.
Abba, 0.
Well, this one has a wide variety of answers for part C. Because it could be, it could be something like this, and you know, I'll even write that up here as well. Two and then 0, 4, 0, 7, and 1, 21, and then 1. It could be this. If the number that the student gave was less than 5, let's just say, then the teacher would give an answer of 0. However, let's say I'm gonna say this, less than 7. Because at 7, the teacher gave the answer of 1. Greater than or equal to 7. It would say 1. Really, a concrete function rule for that pretty much could be something like this, but pretty much those answers could be anything.
So that's the answer.
Yeah, that's it. That's one way of saying it. Not the answer, but there's one answer for that. Okay. Are there any questions about part C? And here's another possible answer that the textbook says. If the student number n is even, like these two right here, guess what? The teacher would say 0. If they're odd, then the teacher would say 1. That's another possibility. Okay. Questions on that? Don't believe that you're going to see that on the exam, because you won't. Well, it's going to be varying answers for that one. Okay, so that's one way as a rule. The second way would be a machine. And you've probably seen machines like this, where you input something, and based on that machine, it's going to do something, and it's going to spit out an output. Okay. So let's say we put in the number 6 in this machine. What the machine does is squares your input. So if I to put the 6 in, if I square it, the output would be 36. Okay. All right, so in this example, here's a couple of function machines that I found here. Okay. So let's say we had these two function machines, and for each one of them, what would happen when the numbers 0, 1, 3, 4, and 6 are going to be your inputs? Okay. So in this case here, we got y equal negative 2x plus 34. Then with 0, 1, 3, 4, and 6. X plus 34. So if we input 0, what would the output be? 34. Okay, because what it's going to do is take the x value multiplied by negative 2 and then add 34 to it. What about for x is equal to 1? Well, the input is 1. What would be that output? 32. Because 2 times negative 1 will negative 2 times 1 will be negative 2 plus 34 would be 32. What about 3? 28. And if I input 4, what would that be? 26. And finally, for the input of 6, what would that output be? 22. Okay. Questions on part A of example 2. Okay, and the other function machine was y is equal to x minus 2 quantity squared. What that means is we input the x, subtract 2 from it, and then square it. I'm going to use those same inputs 0, 1, 2, 4, and 6. So let's say if I input 0, what would the output be? It'd be 4. Because if I take 0 minus 2, that would be negative 2. And if you square that negative 2, that's the same as saying negative 2 times negative 2, that would be 4. So the output there would be 4. And for the input of 1, how much? It'll be 1. That's 1 minus negative 2, and you square it. This will be negative 1 on the inside. We square it, it's going to be positive 1. And for x is equal to 2, the input being 2, what would that output be? So for 3, this will be, it'll be 1. And then for 4, be what? Be 4. 2, and you square that, it will be 4. And finally for 6, it'd be 9. Huh? It's 16, I thought so. 6 minus 2 is 4.
Oh, I put 69.
Okay. And then 4 squared would be 4 times 4, which is 16. Okay, any questions about function machines and how they're used? Pretty much all you do there is just input whatever X is, and then that will be, it's going to do what the function machine says, and you will get your output. Okay, now as equations, here's the other method. Pretty much I won't go through a lot of detail about this one because we can write an equation to depict the rule in, well, this is another example here that's not on this sheet. All right, so if the input is X, the output would be something like X plus 3. That is, we can write it as f of X is equal to X plus 3. So as you can see, where X is equal to 0 for f of 0, that means you take what's inside the parentheses for your f, substituted for 0 for, well, substituted in for X and simplified. So 0 plus 3 would be 3. Then for f of 1, 1 plus 3 will be 4. For f of 3, 3 plus 3 will be 6. For f of 4, 4 plus 3 will be 7. And then for f of 6, 6 plus 3 is equal to 9. And then the ones that we did for the function machines, pretty much they do, here they do give the equation. But here we can write y equal to negative 2x plus 34 as this. F of x is equal to negative 2x plus 34. And the same for y equal x minus 2 quantity squared. We can write that as f of x is equal to x minus 2 quantity squared. Both f of x and y mean the same thing. Okay. Questions on that? Okay. Now let's define what a function is. All right, now a function is a set from set A to set B. That's going to be a correspondence from A to B in which each element of A is paired with one and only one element of B. Okay. That's what a function is. So in other words, you cannot have something from the domain and then the range for that domain will be two different outputs. That means no one X value can be paired with two different Y values. Only one X to only one Y. If it happens that X is with two different Y values, that would not be, you will not have a function. Okay. So let's look at example 3. And in fact, we're going to write these as a function. Anyway. All right, it says here a house was purchased for $78,000. After 7 years, the value of the house was $120,000. Express the house value, which is going to be V of T, in terms of time in years. Okay, now let's think about this for a moment because Because this function here, this problem does have a pattern that's given to us. All right. Started off at $78,000. And then after 7 years, his value was $120,000. That means it's increased at the same amount. So what would be 120,000 minus 78,000? Let's find that out first. 42,000. So from the first year to the 7th year, it was $120,000. So this is the first year. Let's do this. The difference between 7 and 1 is what? Well, actually, let's think about this. It's after let's don't forget about that. After 7 years, 42,000 divided by 7 is how much? 6,000. So the value of the house increased by $6,000 a year. And now we can express the house's value in terms of the T, where T is the number of years. All right, it started off at $78,000 plus it's increased each year by $6,000. So this will have to be 6,000 times T. So that would be the function for that problem. Because we first have to subtract 78,000 from 120,000 to get the difference of 42,000. And it says after 7 years, so that means when you divide 7 into 42,000, you get 6,000. So the value of the house increased by $6,000 a year. Started off at 78,000, and then we're adding $6,000 per year. This would be the function for that problem. Okay. Questions on that example? All right, here's example 4. A company car makes 10 bridge bulkheads for $54,000, while 18 bridge bulkheads cost $59,200. What is the cost, denoted by Y of X, of producing X bridge bulkheads? All right, now let's think about this one for a moment. All right, so 10 bridge bulkheads for $54,000. And 18 of those bridge bulkheads are costing $59,200. Let's subtract those two. So there. What's 5,400 from 59,000 to 54,000 from 59,200? 5,200. Okay. And 18 bridge bulkheads cost $59,200. Okay, what's 18 from 10? I mean, yeah, that's 8. So if I do this, if I do 5,200 divided by 8, what would that be? 650. So each of bridge bulkhead would be like $650. So that means that Y of X would be 2, and those 650X, and then plus that was not a good problem that I chose for this one right here. I'm not sure where they're getting this as the answer. Because that's actually the correct answer, but I'm gonna have to get back with that example number 4 and explain how they got that answer as the plus 47,500. I do know that if I subtract 59,200 minus 54,000, that would be 5,200, and subtract 18 minus 10, that would be 8, and divide 5,200 by 8 to get 650. But for the 47,500, I'm not sure where they're getting that from. Okay. But I will come back to that. Okay. All right, take a look at example 5. And that's this. The cost of a cab ride in dollars is given by this. C of X is equal to 1.4 plus 0.5X, where X is the number of miles. What are the charges for a ride of 27 miles? Okay. Now that's just a direct substitution for this one. Okay. I'll come back to that previous example next class. All right, but for this one, our function is C of X is equal to 1.4 plus 0.5X. So now for 27 miles, X is the number of miles. So we just simply replace the X in this function with 27. So this will be 1.4 plus 0.5 times X, which is 27. So if I do first the 0.5 times 27, I'm going to get 13.5. And what would 13.5 plus 1.4 be? $14.90. And usually money amounts are written with 2 decimal places. So the charge for a ride of 27 miles will be $14.90. Any questions about example 5?
Right equals 1490.
Yeah. Yeah. Because see, we're dealing with money amounts. Yeah, because money amounts are always to 2 decimal places.
Oh, I understand now.
She was just asking like, why didn't
I could have.
It's okay, don't have to. I'm just.
I mean, no, no. Any other questions? Okay. Let's look at this one right here. A long distance phone call costs $1.30 for the first minute, plus 20 cents each additional minute. What is the cost of a 25-minute call? So in this case here, we need to write a function for that. All right, a long distance call, it costs $1.30. So I'm going to say the cost in minutes. I'm letting M be the number of minutes and C be the cost. That's going to be $1.30 for the first minute, and then plus 20 cents for each additional minute. Okay. So I know 20 cents. Now, for each minute after the first minute, I have to write this as M minus 1. Oh, 20. Yeah. I'm just writing it as a function. And then for a 25-minute call, I'm going to substitute M with 25. That would be $1.30 plus times M, which is 25, minus 1. And that would be 24. $1.30 plus 0.20. And then 25 minus 1 would be 24. And then we go ahead and simplify this. I'm going to do 0.20 times 24. That would be 4.80 or $4.80. And $4.80 plus $1.30 is how much? $6.10. So that would be the cost of a 25-minute call. All right. Questions on problem example 6? Okay. Now, of course, functions can be represented by equations, by the way. And here are a few equations that we have here. And from that, we want to determine whether each equation or inequality represents a function and which one does not. And in each case, X and Y are going to be real numbers where X is in the domain and Y is in the range. And if your answer is not a function, then explain why not. All right, now let's take a look at part A. We got x plus y is equal to 2. Now, in this case, would that equation represent a function? So here we got x plus y is equal to 2. I might need to give you a little hint on this one. If you look at this y, what's the exponent for y? Right. If your y is to an odd power, like 1 y to the first, or y to the third, or y to the fifth, that tells you you have a function. So this one, x plus y is equal to 2, is a function. Okay. And also, something else. If I was to solve this equation for y, that means if I subtract x on both sides, that means I'm gonna have y is equal to negative x plus 2. For this equation, I will only have one x going to only one y. So for every x value, I will only have one y value. So that tells me I would have a function. So x plus y equals 2 is a function. Okay. Now, questions on part A, by the way. Okay. Take a look at part B. We got x minus y is greater than 2. I don't want to know if that's going to be a function. This one, because of the fact of this, because you have this inequality, we're going to have multiple values that would be greater than 2. And by the way, if you were to solve this equation or get y by itself, it's an inequality. This is what you'll have. Negative y is greater than, let's say, negative x plus 2. And this goes back to the days of algebra when you divide by negative. This inequality symbol changes from greater than to less than. Now, you're going to have to think about this. Even with an inequality, you're not going to have one value of x where y would be less than whatever. You're going to have multiple values of x where y is less than whatever x minus 2 is. So in this case, this graph or that inequality will not be a function. And the hint for that would be of that inequality symbol. Because with inequalities, when you solve the inequalities, you're looking not just for one definitive value of y, or X or whatever, you're looking for multiple values for that variable that will satisfy that inequality. And here you're going to have multiple values here that will satisfy the line X minus Y is greater than 2. So that's not a function. Questions on part B? Now part C looks like this. Let's see, Y is equal to X to the 5th plus X. Would this be a function? Well, that Y is to the first power. I mean, any X, you're only going to have one Y value for that X. For whatever X you substitute, you're only going to have one Y value for it. So it is a function. I know that's going to be hard, but for X, what?
If you said that Y,
because of the inequality symbol greater than. Yeah, because the fact is with greater than, you're not looking for greater than or less than or any inequality. Those are the ones that are going to have multiple values there. So that's why that can't be a function. This one can be a function. Okay. Because I can use X equals 2. I can do 2 to the 5th. That's what 32 plus 2 will be 34. There's only one Y value for X equals 2. Any other questions on well, any other questions? All right, now for part D, this has X times Y is equal to 7. And the restriction there is that X is not equal to 0. It is a function. By the way, if you try to solve for Y by dividing both sides by X, as long as X is not equal to 0, it's going to be this. Y equals 7 over X. Because if it was 0, then it would be undefined. But it gives you the restriction where X is not equal to 0. So here, let's say X equal -7. 7 divided by -7 would be -1. You're only going to have one Y value for it. So it is a function. Okay, let's see, part E. Here we got Y is equal to the absolute value of X. Would that be a function? It would be. Because for only one X, you do the absolute value, you're going to get only one Y value for it. So this is a function. Now, what about F? Here we got what absolute value of Y is equal to X. And I want to determine if that's going to be a function.
would that be no, since there's no?
Right. Here's an example. Let's say at the absolute value of, and now let X equal to 5. If you recall, back in college algebra or wherever, when you have the absolute value of Y equal 5, you're going to have two equations. Y equal 5 or Y is equal to -5. So here you got this X value with two different Y values. So this is not a function. Okay. Questions on part F? What about part G? Here's not a function because of the y to the second power. And if you take an X value, replace it for X, you're going to end up with two different Y values for it. So that equation is not a function. See, and finally, Y is equal to the square root of negative X. It is a function. Okay. As long as X is, I'm going to say greater than less than 0, this would work. Okay, so it is a function. All right, any other questions? Well, any questions about that example here? And I realized that was a kind of a difficult one to determine whether it is a function. Okay. All right, question.
Ought to not be a function if it's raised to an even power.
It's
or
not.
if there's multiple values of y.
Mm-hmm.
Then that's
Not a function. Any other questions? Okay, we'll stop right here.